welcome to the second session of reflection on our future, which is, as you just heard, dedicated to meta trends that Europe must not miss. When we tried to put together this specific exchange on a forward-looking perspective of Europe, we were reflecting on what meta trends we should focus on. And we came up with so many that we are actually facing that we possibly could have filled the entire day and possibly the rest of the week. So we decided that we need to focus. We need to focus on two to exemplify the type of challenges that we are facing as a society and where Europe actually needs to engage to preserve its spots in the geopolitical landscape and its competitiveness. I'm very humbled to have two outstanding personalities with me today. Two people that you probably have one of the rare opportunities to see without bodyguards today with us, because normally, if they are in their natural environment, they are rock stars. They are working on very distinct fields of innovation, groundbreaking innovation, that we are called to connect to in order to ensure and secure the sustainability of our society. We've decided to take a zoom in on the area of life sciences and discuss with the first of our invitees on stage here with Sara Mangsbo, Dr. Sara Mangsbo, who is a scientist in cancer research, in immunotherapy in cancer, trying to go after the biggest defy that we have in healthcare, which is to cure our common enemy, cancer. In a way, you can take it that Sara is dealing with derailed nature, because cancer actually is derailed nature in our human bodies. And she will talk about her journey in making that big challenge happen. On the other side, we have with us Moritz Von der Linden, who is a serial entrepreneur and is working with his company on finding a solution to the big challenge of energy supply to humankind by finding an energy source that is non-pollutive and unlimited and can fuel our economic and human sustainability. We will start off with a short presentation from Dr. Sara Mangsbo on her work on cell therapy. She is working with the Upsala University and responsible for the research on immunotherapy in cancer in that organization. At the same time, she is a serial entrepreneur. She's currently the chief scientific officer of Strike Pharma, which is a pharma company that is also working in this field of immunotherapy. And she will share with us her insights in the research for a cure to cancer. Sara, the floor is yours.
Thank you. Thank you, Uli, for inviting me and for giving me this opportunity to speak to you today about a topic which many of you probably relate to, in order for you to give hope to your close ones. We tend to look at health management, and today we also heard about sustainability in terms of using our soil, using our collaborative natures, and how we can use innovations to actually create a sustainable environment. And this is important, right? Also in terms of that we look at the global goals. We are actually obliged to work for the global goals, right? And we should look into prevention, and we should look into maternal health and global health and give everyone access to a health system. So why is immunotherapy so intriguing? It's because you can actually prevent diseases with vaccines. We've seen it. And you can cure cancer with immunotherapy. And I think that is what brings the attention to this field, right? So I've been in the field for a long time. I've been working with cancer immunotherapy since before it became a huge success. And before it became a huge success, no one cared about this field. No one thought that this would actually matter for patients. And then we saw that it started to matter because we saw that patients with metastatic melanoma that only had a 10% 5-year overall survival gained up to 60% survive for 5 years with immunotherapy. And with that came a lot of opportunities because all of a sudden we needed new tools to predict how safe these therapies were. And I had the chance, with the support of people like you that invest in companies, to start my first company in 2014, Immunid, which creates a service for global companies looking into how infusion reactions to drugs when they meet blood appear, as a way for us to ensure that first-in-human trials are actually safe for the ones that say that they go in and experiment a little bit on themselves for the benefit of humanity. And with this explosion of new therapies, we've also seen that we've gone from big blockbusters to precision medicine. And I think that the next generation of drugs in terms of immunotherapies will be combining the knowledge of precision medicine and immunotherapy so that we bring fields together. And why is that? It's because of the data, right? So we are kind of a little bit lost, but we are finding our way. We are bridging, like we did here between Sweden and Denmark. We are bridging ourselves using the data. We are understanding who to treat with what we should treat. And I think that if we look at the thought leaders that were asked, what are we looking forward to in 25 years? Elizabeth Jaffe, she really looked into this, and she was indicating that we need to look into cancer vaccines. And with the wealth of data we have, this will become the reality in our future. But that means that we also need to look into sustainable healthcare, because with precision medicine comes costs, comes challenges in terms of predicting efficacy, and there are challenges with production. So there are many things that we can develop in terms of sustainable precision medicine. Where we started off in 1891, when we looked into the birth of immunotherapy, it was very crude therapies, right? We used toxins that we injected even in the bloodstream to activate an innate immune response with a hope to actually sometimes cure cancer. Then in 1972, we saw Stanley Cohen and Herbert Boyer publish the birth paper of biotechnology, where we learned that we could harness proteins and build proteins to our benefit so that we could tweak the way we use therapies. We could replace proteins, and we could even control processes in our body with this technology. And now when we can control that code, it made it feasible to build new drugs based on proteins that we could before only imagine. And here, I just wanted to show you sort of the David and Goliath situation in terms of what we're trying to achieve, right? So we have in purple here a big tumor cell, and then we have the small T cell in red. And what we are doing is actually pharmacologically intervening between these interactions so that we are trying to kill that big tumor cells with our tiny immune cells. And the future, holds more promises than we could ever imagine. If we are looking at the innovations around the mRNA-based vaccines, we had multiple key innovations. One of them, of course, the fact that we modified the RNA in order for us to not react too strongly to the synthetically produced RNA, and thereby could introduce RNA in our bodies. And this was, of course, given the Nobel Prize in 2023. And then we had big steps in formulation science, which meant that the mRNA could actually be delivered to the cells. So what are we looking at? A lot of the formulation sciences around lipid nanoparticles that are the key to deliver mRNA is investigating the charge basis for where these molecules go. If you change the charges, you can go from delivering these lipid nanoparticles to the lung or the liver, and then turn it into delivery into the spleen. Right, so simple changes can be disruptive scientific breakthroughs in healthcare. And the fact that we can target different organs makes it feasible to see that RNA can be something that is just scraped off the surface right now with the cancer vaccines and the vaccines used in the pandemic. But maybe we are seeing a whole new era of targeted delivery of these. And you all talk about antibody-drug conjugates right now as the big thing, but the fact that the cargo they are currently carrying in the drugs that we are investing in, that's not innovative cargoes. It's more traditional use cytotoxic substances, and we have to look into what new cargoes we should deliver with our capabilities of using antibodies to steer cargoes to the right cells in our body. So what have we been through the last 30 years? Well, we have seen the introduction of preventive vaccination in terms of actually preventing the infection of papillomaviruses with Gardasil and then preventing tumors to occur later in life. We have seen the introduction of many different checkpoint inhibitors that boost our T cells to kill off cancer cells. Among them, pembrolizumab, we have durvalumab, we have nivolumab, we have avelumab, many of them there. We also, of course, have seen the true compassion of the development by BioNTech and Pfizer in the pandemic situation, where we used all the knowledge that BioNTech had developed in the cancer field and then switched that to the use for humanity to prevent SARS-CoV-2, the deadly disease. And then what we're looking at in 2030 is the fact that we could actually use the genetic information from the sequencing of tumors to our benefit to create individualized vaccines. And this is today very costly, so this demands new innovations so that we can do this from the benefit of all patients and not just the fortunate ones that get this medicine because they have the money to pay for that. So we see that these vaccines go well together with the medicines that boost the T-cell activity. And when we introduce the vaccines together with these T-cell boosting therapies, we can even see that responding patients in pancreatic cancer, which is seen as incurable, these responding patients in red here, they get a much longer relapse-free survival. And we are just scraping the surface here. We have much more to do in terms of data mining, much more to do in terms of understanding how to design these vaccines and how to make them sustainable for our healthcare. The future will tell us if this becomes the reality, But I also believe that we have to face the fact that we have to have a competitive industrial landscape, a regulatory fast track we saw during the pandemic. We have to see if we can maintain that. We have to also, of course, allow ourselves to be leaders in investments and not just what everyone else is doing. Are we doing ADCs because everyone else are doing the ADC track in investments? Or is there a tweak to that where we can bring two technologies together? Can we change the way we lead clinical trials so that clinical trials are still done in Europe? I would like to see that. And I also would like to see a fast drug uptake in Europe. But of course, it is important that we do this with a focus on innovations for sustainable healthcare and that we keep a focus on our education for the future leaders of our countries. And I believe that targeted delivery platforms will be a big breakthrough, which will combine all of our novel therapy tools ahead. And there are things that we may not even imagine that will happen if we bring them together. And if we start to allow ourselves to use data, to mine the data to understand who to treat and when to treat, we will have a revolution and we will treat the right patient, which will also be cost effective, right? So I come from Uppsala in Sweden, and I just wanted you to get a flavor of how we have developed our biotech and pharma culture. So we have a legacy where we saw the formation of Pharmacia in 1911, a move of Pharmacia to Stockholm, from Stockholm to Uppsala around 1940. And this led to a medicine which shouldn't even today be called the medicine, the energon pillar. But it also led to the fact that we gave birth to a number of different companies, like Thermo Fisher, still residing in Uppsala, as well as Cytiva, a very important company for purification of proteins around the world. And also, of course, later, Pharmacia was sold to Pfizer. So if we look at Uppsala, we are part, of course, of Europe, and we are contributing to life science and want to sort of spur the innovations throughout Europe. We are about 250,000 people in Uppsala, and we are about 6,000 individuals that work in life science. We have big companies like Cytiva and Thermo Fisher, as well as Olink, who have been brought up in this soil of life science. And in Sweden, we contribute to a lot of different life science technologies with the small enterprises as well as the larger companies that stem from this soil. And it's because of the two universities, the Agricultural University as well as Upsala University, which of course has generated a collaboration between the university and the industry and many innovative ideas that have been given the Nobel Prize throughout the years. So if you ever want to come to Uppsala, just knock on the door and give me a call, and I will take you around and show how we bring life science out to Europe. Thank you for me.
Thank you very much, Sara, for those insights in a very, very exciting topic that is potentially closer to each of us than we actually think. Because if we take statistics, today we live in an environment where we have to go by the assumption that we've got the likelihood of 1 out of 3 or 1 out of 2 even to contract cancer somewhere in the course of our life. And we also know that cancer has been a battle for the pharma industry for many, many years, dealing with blockbuster drugs that more resemble clinical trials in real life when they applied, because we do not know how much efficiency actually they have when it comes down to the individual case. And you are here directing something that is taking a totally different view of individualizing actually the therapy. If you take your perspective from today, how close are we from curing cancer rather than managing cancer?
So we are.
Can we put the mic back on?
Is it working?
Yeah. No.
So we are, in some cases, already curing cancer for some of the tumor types, especially the ones where we see a lot of different mutations that the immune system can react to. And that is an amazing track to follow when you see patients with metastatic melanoma, which is spread all over the body, and these patients are completely cured from cancer, right? But we are not curing all cancer forms. And I believe that the data behind which mutations that the immune system can respond to is a key factor that we still have not learned to manage, and that we also need to design our clinical trials in a way where we can allow ourselves to test the hypothesis of an individualized vaccine setting, but on the group level, and it's not so easy. But if we get there, I truly believe that we get a cure for more people than we do today. But of course, this means that we cannot stop this. We have to allow ourselves to work on data mining. We have to allow ourselves to combine novel technologies and not just see one technology as a fixed entity which cannot be changed in the regulatory environment, because then we don't progress, and then we don't develop, and then we don't challenge ourselves, which we have to do.
I was referring to the relationship of this new type of therapies that are developed with the traditional pharma industries. And if you look at it from the perspective of the businesses of pharma industry out there, and the approaches that you're taking, it is not only taking healthcare and treatment of cancer in human bodies to a totally different level. It also potentially revolutionizes, or at least endangers, the traditional business models of the pharma industry. So let me ask you a question. How big a friend are you with the pharma industry, and how big a friend are they with you?
So I think that this is something which has already changed with the precision medicine tools. In early 2000, we saw that everyone wanted a blockbuster in terms of the targeted therapies. We made studies where we used the tyrosine kinase inhibitors on all patients, despite they didn't have the EGFR mutation or not. So this is in lung cancer, and then all of a sudden no clinical trials came out positive, and there was just a big failure and a big economic loss, right? So I think that the companies, they realize this, and you see this with AstraZeneca and osimertinib, right? It's a huge success when they manage to harness the knowledge of the genetic code of lung cancer, and they've developed osimertinib in record time as a targeted therapy to treat T790M mutated lung cancer. And when you see this, I think that the big pharma is already there. They know that they have to use the big data, they have to use the knowledge to get the clinical trials through with the data they need to get approved drugs. And this is the business case they work with. And we need to also make sure that immunotherapies go the same path, that immunotherapies are not just seen as blockbusters, but just use the knowledge we saw of the trends going from 2000 to 2010 and building medicines for specific patient groups is what we need to do for immunotherapies as well. And we can do that, and big pharma, I'm sure they are on board.
Very interesting perspective, thank you. Before I pass on to Moritz, let me ask you one more question. we all know that in the bio industry, in the biotech industry, we are in a race against time with the problems that we seek to solve, the therapies that we would like to bring to the market. We're in competition between sectors and companies. Obviously, we just mentioned the dynamics in the pharma industry, but we also, especially speaking from today's perspective, in a competition between economies and continents. So let me ask you provocatively the question, who has got the better science, US or Europe?
Yeah, it's really provocative, right? Also in this room. So I live by role models, right? And I'm gonna take a sort of a way here to say that my role models have really been Özlem and Ugur from BioNTech during my upbringing into this field. And saying that, I really think that Europe has done a great job to spur the innovations and being part of the innovative landscape. But I would like to say that I think sometimes US is best at growing big. And I think that we have to grow a little bit bigger in our efforts in the pharmaceutical landscape to be able to maintain the small businesses as well. Sweden had big pharma businesses for a while, and then we sold it off. And I'm a little bit afraid of that, so I'm hoping that we can use the power of our diversity to bring back big, bold. Yes.
Brilliant. Thank you so much, Sara. We are going to come back to a couple of topics that you have touched on after the talk of Moritz. Moritz is going to speak to us now with respect to another massive challenge that we have in the 21st century, that we have as economies, that we have as individuals, that we have in a geopolitical context. Moritz is a serial entrepreneur in high-tech companies. He has got a long-standing history, has made many successes happen in that field, also in the financial services industry, so it's totally unrelated actually to the business field that you're doing today. Today he will talk to us from his perspective as the CEO of Marvel Fusion, which is a company that is doing groundbreaking research and actually meanwhile far beyond research in the field of nuclear fusion. Nuclear fusion is this type of energy generation or potential energy generation that has everything that the power of nuclear energy has without the drawbacks of having radiative waste to deal with and radiation in the production process. Moritz is going to talk to this journey of Marvel Fusion to us and giving us a perspective, how far are we from having the energy generation of the sun on the planet Earth? Moritz, the floor is yours.
Thank you, Uli, and thank you for the IAF for having me. Europe faces an enormous challenge. We require energy, and we require more energy than we think we do. And there's a number of problems, issues, and then EU-specific luxury problems that we think we can afford that are in the way. Number one, we're looking to decarbonize, not because it's a goal in itself, because we do see that it's an absolute necessity. As I think we heard from Jan Giesbert, this is an opportunity for Europe. We want to protect our old economies, right? As we see here, steel and manufacturing and chemical production, while we decarbonize those industries. And looking at that airplane, we've also set our goal on decarbonizing other areas that may emit less CO2, but that are still loved by EU politicians. This is very challenging. Just the chemical sector in Germany requires as much electricity as the country consumes as a whole at the moment to decarbonize. If Lufthansa puts their 700 airplanes on sustainable aviation fuel, they need half of the electricity consumption of Germany. We have no idea how much energy we need. And then while Jan Giesbert pointed out a lot of very, very good points, it's also, let's say, a European view, because take a guess what the #1 cause of death is in Africa. It's diarrhea. It's because people do not have sanitation. They don't have running water. It's very, very basic. Do you think they care about enhanced photosynthesis in the ground when their kids need to go on the street to take care of business and have the risk of dying while doing that? No, they don't. India has an economic growth, what we have an inflation rate. They have an energy hunger that is through the roof. They're currently building or planning 400 coal plants. And that is because our current efforts fall short. Wind and solar, in the most optimistic studies, will probably supply around 40% of global energy demand by 2050. Given Europe's geographic location, it's going to be a lot worse. Fission is too expensive. EDF is currently building Hinkley Point C in the UK, 3.2 gigawatt for 42 billion. You take that pitch to re-elected Prime Minister Modi, he's going to say, I'll take the 42 billion, but instead of 3 gigawatt fission, I'm going to build myself 40 gigawatt coal. So if you want to be successful, you got to be competitive. And Europe needs to do two things at the same time. We need to ensure that we can have an energy source that protects our standard of living, our standard of life, but at the same time, that is really putting a dent into climate change globally. Fusion can do that. It's clean, it's safe, it is absolutely abundant. For around 100,000 years, we estimate we have the fuel for our type of fuel on this planet to power Mother Earth. It's competitive. We want to get in below 5 cents per kilowatt hour. And it's reliable baseload. And that is what we need to decarbonize some of the most pressing areas in our industrial sectors. Now, we've come a long way. The National Ignition Facility thankfully showed that fusion does actually work. Unfortunately, for all of us, it is so inefficient that it's not suited for commercial use. So what we need is a non-linear breakthrough. Experts always take the past and extrapolate that to the future. They don't see the improbable, the impossible, something that people thought we could not do. Earliest non-linear breakthrough was around 700,000 years ago, when somebody came up with a way to tame fire. All the experts back then said that's not possible. In the day and age we live today, landing rocket boosters back to Earth, all the experts at NASA said it is impossible. And we just heard from Sara about mRNA. We are a sister portfolio company of BioNTech. The founders fought the hardest wars against the existing big pharma industry because they wanted to protect their products, and all the experts says, this will never work. I personally have BioNTech in my body against corona. It's probably one of the greatest medical breakthroughs we've seen, non-linear breakthroughs we've seen in the past decades. So what do? We move away in fusion from trying to reach very high temperatures. Essentially, you're looking to strip electrons of an atom core, overcome the Coulomb barrier that keeps two atoms away from each other, to essentially reach the nuclear force that pulls them together, fuses them, and the product that's coming out of them is lighter than what's going in, and the difference, according to Einstein, is energy. We move to kinetic energy, so away from temperature, but we use diode-pumped modern lasers to irradiate nanostructured fuel targets who then accelerate ions into the actual fusion fuel. It is a nonlinear breakthrough. All of the experts say this will never work, but it does. And we have shown experimentally, very, very successfully, that it actually works extremely well, and it works so efficient that it is suited for a power plant. Now, unfortunately, I believe in this movie we don't have sound again.
Marvel Fusion is developing the ultimate clean energy solution, using laser-driven fusion for abundant clean energy without long-lived radioactive waste. This Nobel Prize-winning laser technology generates laser pulses, measuring in femtoseconds with enormous photon pressure. In the reaction chamber, multiple pulsing lasers converge on the fuel target, which is composed of alternating nanostructured rods and solid fusion fuel. The rods act as an entrance for the laser pulses, coupling the laser energy efficiently into the target. The pulses cause electrons to rapidly evacuate from the rods, leaving behind positively charged nuclei, which are then accelerated to the fuel layers, which compress and heat up, starting fusion. The produced charged particles are converted into electricity directly. The remaining neutrons and X-rays generate heat against the first wall and are converted into electricity. Fusion is the ultimate clean energy solution for humanity, and Marvel Fusion is leading the way.
So in 4 steps, we want to move to a commercial power plant. We've teamed up with a number of high-caliber partners in Europe, also in the US, to have a proof of concept showing that this actually works. We're currently building our technology demonstration facility in Colorado. Why? Because we didn't get the money in the EU. That's why. That's a big problem, and I'll come back to that in a little while. And we've signed a partnership agreement with Lufthansa to be the first airline to competitively produce sustainable aviation fuel for their fleet. Together with Siemens Energy, we're currently in the specification phase of this power plant that's geared to become online in the early 2030s. And then we're looking to industrialize and scale globally. This is some of our scientists working at the Eli NP facility in Romania. It is the world's leading short pulse laser facility. These systems were built by French company Thales. Those 2 lasers produce 10 petawatts each. 20 petawatt is around 400 times the entire installed energy capacity on this planet in peak power. It's incredible physics you can do with those lasers. We need this peak power to accelerate our ions in the fuel. Europe is leading in these short pulse lasers. In the last 5 years, 2 Nobel Prizes were awarded, one to French scientist Gérard Moreau and one to the Hungarian-German scientist Ferenc Krauss. We're the epicenter of short pulse lasers, both on the science and then on the industrial side, with Trumpf and Thales manufacturing some of the key components and systems in this field. Yet, our demonstration facility, this is a rendering, is in Colorado. Because next to the German Agency for Disruptive Innovation, Sprint, who provided 45 million in funding for the development of these lasers, we got 100 million in the US from the Colorado State University and the Department of Energy, 100 million that we couldn't find in the EU. And that's why this demonstration facility sits in Colorado. As a CEO, it's amazing. We'll be the first laser fusion company on the planet with a full proof of technology. It's absolutely incredible. As a European citizen, it's a shame. It is a shame that it sits in Colorado and not near Strasbourg or near Amsterdam or near Frankfurt or somewhere else in the EU. It is a shame. We're leading the pack. We're most advanced. We've done the most experiments, most validation. We've built an industrial ecosystem to move on this power plant. And we've found some of the best funding partners to pave the way to do that. The race to be successful here is on. The bold decadal vision for fusion was passed in 2022 in the US. China has formed a large coalition near Shanghai to move on this opportunity. France, with its France 2030 program, took a bold step, and also Germany announced plans to support fusion. But here's the thing. We're losing the race. 2% of the global investment in fusion was in the entire EU. And that is the key reason, if we don't change this, we're going to lose this race. And if parts of what Jan Giesbert told us is true, this is the absolute foundation of everything in order to achieve other steps. Clean water, well, you need to produce it. If you want to decarbonize, it requires enormous amounts of energy. Hydrogen, probably politicians try to make us believe it's an energy source. Let me tell you, no, it's an energy carrier. We need to make it, and it requires energy to make it. So this graph here, again, is just terrible. It's just absolutely terrible. And everyone in this room needs to think about how we can change this. And this is not only about Marvel Fusion, this is the entire EU, this is every fusion company in the EU, and they received 2% of global funding. So in summary, we can be fast. We can be ultra competitive. And we can be in Europe. But it takes probably every one of you in the room, and then beyond that, around our ecosystem and in the ecosystem around fusion as such, to change this funding picture, to have a shot at goal, to make this vision come true, for which we've worked extremely hard over the last years. I've dedicated my professional life and took a lot of sacrifices in my personal life to make this happen and to bring it to the point where it is today. I believe that the science and the technology is ready. And why do you think the US gives us 100 million? Because we're crazy, this will never happen? No, they know very well this will happen. And while there are still challenges ahead, and I don't want to small talk those challenges, it's an enormous undertaking. But what we can achieve is one of those world-changing non-linear breakthroughs, an abundant energy source for the planet and for humanity that will combine some of these goals that we've heard from Jan Giesbert with a sustainable prosperity that will allow Europe to have its seat at the table in the world, to have its diverse voice heard, to protect its values against the challenges in the world. And I think the risks that are still out there can be tackled, and they should be tackled to achieve that goal. Thank you very much.
Thank you very much, Moritz, for these inspiring, but at the same time also sobering words that you had for framing the challenges for us as Europe. And we are definitely going to touch upon in our discussion now what it takes to make things happen in Europe and keep this groundbreaking research in Europe and make it flourish. But maybe before we get into that, let me make an attempt to get closer to your DNA as a entrepreneur in the high-tech space. When you started off Marvel Fusion in 2019, the world of physics basically declared that you're going crazy because you're going after the unachievable. Nobody actually at that time was thinking that even the scientific break-even point would be reached with Marvel Fusion, let alone having it as a net contributor of energy, which in the meantime has happened. What made you go crazy in 2019?
I believe three things. Limitless naiveness, which you need as an entrepreneur, otherwise you don't attack these kinds of things. Then the finding that probably most of the existing approaches will not work. Having consumed billions and billions and billions and billions with some of the brightest minds on the planet, most likely they're not, there may be credible physics, but they may not be suited for a commercial power plant. And at the same time, analyzing that, how do we have a chance as a startup? There is national labs with billions of funding per year, universities, other institutes that have been around for decades with a lot of funding, incredible scientists working on this. So how do we have a chance with a startup that will have limited funding, that will attract talent over time, and that we do see this chance of having Marvel Fusion in a position with a nonlinear breakthrough to actually get to commercialization. And then lastly, I think the breakthroughs in laser technology, you always, the loveliest physics model is worth nothing if you cannot build it, if you cannot transfer it into reality. And we saw that, unlike other technology areas, what we do with lasers today was unthinkable 10 years ago. And probably what we will do in 10 years is unthinkable today. So the progress of this key enabling technology was just astonishing, that we felt this will fulfill both the technology requirements that we have for the physics path, while at the same time have a price degression in its components so that it becomes commercially very attractive.
Very interesting. You mentioned two big blocks of relevance in the debate around innovation in a European context. One is obviously the topic of funding, and we are going to touch upon that in a minute. The other one is linked to how do we get research that is done in a very dispersed environment in research institutions that are spread across Europe. How do we actually get that out in the market that it becomes applied research? And I would like to ask both you and Sara, how fertile is the environment for scientific research and making it to the market in a European context? What is your view on that?
So, firstly, I think we have, incredible science and research in Europe. I mean, in all humbleness, modern physics was invented here. It is French, Austrian, German physicists that paved the way to this. Schrödinger, Einstein, Heisenberg, just to name a few, we're really good at physics. And thankfully, you know, the money that got invested into fusion in the US doesn't substitute for brain, but obviously it is a disadvantage once you move on building actual hardware. The path to extract that knowledge and apply it is you know, it's pretty rough, because even trying to get a professor out of university to work with us for 2 years and see, you know, can we make something out of it? Have a trial and error phase of 2 years, and then if it doesn't work, professor goes back. Very, very, very difficult. And I think here we need to become a more, you know, risk embracing to allow a scientist to just have a shot at it, right? So Sara is a professor, but she's also an entrepreneur. That's how it should be, to have you know, the ability for world-reading research, but also have a lab-style test environment where you can see, hey, how can we actually make this work? And if you believe it or not, so in the Department of Energy funded what is called a RISE Hub. We're the only foreign fusion company that got awarded with funding, and at the ELA&P facility in Romania, we're the only commercial user, which is kind of crazy when you think about it, that there isn't anyone else using these laser systems to advance an actual product for the real world. So there's definitely room for improvement, but it's also linked to, I think, financial incentives that I believe need to, you know, beefed up specifically for science and research.
Sara, what is your view on that?
No, I agree with that. We have to start to be more inclusive across the industry and academia. I think that we have for 20 years now in Sweden tried to build a platform for our special case. So you may all know that we have something called the professor privilege or teacher exemption in Sweden, which is kind of unique, where the innovation actually is owned by the person who invents it at the university, and the university is government, and the government doesn't take ownership. And that has been both something that has been great for startups in Sweden. So we have maybe the best startup scene in Europe based on that. But we still lack the bridge funding to grow big. So I think that we are really good at the startup scene and allowing teachers to take part in the early phase of companies. We are allowed to be part of that, and I'm really happy for that, because I think it brings back a lot of questions that I need to take on as a scientist. If I wouldn't be in the industry, I wouldn't know about it, and if we cage ourselves in, we are too limited. But the fact that we can't then grow out of the persons to start a company, we need to have, like you say, the muscles and the finances to find the people that then take on the journey of growing that company. That is probably not me. I'm not the good person there. I can start, but someone needs to build. And I need to find people that build together with me, so that I can also be part of new journeys, which I am good at. So if we can find that ecosystem together with the financial muscles, we're good to go.
We have probably a fuel for discussing an entire day about the fascination of your both approaches to innovation in Europe. But since we are limited in time, I would like to ask each of you, as basically a son and a daughter of the European continent, of the European innovation system, what does it take, from your personal perspective, to keep you and your innovation and your endeavors that you're putting out there on the business side, to keep them in Europe? Sara, maybe you have a first go.
I think we need to just be more bold in the investment and take it longer, because right now there is no other option than eventually to go to the US and do the clinical trials and get the investments done there, because that's where the money is. And if we are to stay and if we are to grow bigger, we have to get the financing muscles here in Europe, I believe. Daring to take the risk, we have to dare more.
Yeah, so I believe that it's three things. We have, as I said, a lead on the science. These types of lasers and also the nanostructuring technology, we're leading this. We have in Belgium the IMAC facility, which is one of the world's leading and greatest and most impressive semiconductor research facilities who help us work on these nanostructures through lithography and etching. So we have this science foundation, which I believe is outstanding. Then we still have an industrial ecosystem that is capable of delivering these components, and that I think is also able to industrialize and scale globally. I've mentioned Trumpf-Thales, Siemens Energy. There's BASF, who we're working with on some of the chemical compounds for the fuel. So I think then there is obviously what's missing in this is customers, right? So I'm like, kissing feet and other body parts at European industrials, wondering why they're not willing to, be an early adopter, become our customer. That's what we really need. And also, European governments don't always subsidize. I mean, Germany, since Fukushima, spent 700 billion on the famous Energiewende, and it's basically a blueprint how not to do it, right? So don't subsidize, become a customer. There is no reason why, Macron's Dassault Falcon 7X jet shouldn't be run on sustainable aviation fuel rather than, Lufthansa or Luxair here. And it's, it's really the third thing is backing what Sara said, is that we need to have structural changes in financial flows in the EU. We need to allow that, for example, the German pension system is opened up for becoming a capital-based pension system with allocation to high-risk areas, venture capital, private equity, so that some of these capital flows are allocated into these areas. As Jan Giesbert says, there is enormous amounts of money here. Whether it's private equity, whether it's families, Europe is still extremely rich. But as you saw, the money, is rather invested in another lovely office building on Bahnhofstrasse in Zurich than finding its way into some of the required, megatrends in healthcare or in fusion that are key to the future of the EU. And, we are now something like 3.5% of global population. We're a fly on the wall, guys. If we want to have a seat at the table, we got to work for it, and we have to stand up for it, and we have, unfortunately, to take the risk for it.
Thank you, Moritz. This is a very powerful appeal for closing this panel. I think taking your words, Sara, your words, Moritz, and reflecting on the slogan of today, 30 years bold, and extrapolating it to the European sphere, we have to say we have not been bold enough. We need to get bolder in taking risk and taking also the money to put it behind the innovation that we need to sustain Thank you very much for being with us today and sharing with us your valuable insights. Thank you so much.
Thank you.